Welcome to Advanced Mathematics, Trigonometric Identities and Formulas, Classwork Part D walkthrough. As always, I encourage you to attempt this on your own, and perhaps even using the published answer key. And if you want a little extra information or guidance or insight, go ahead and watch this video. This is a one-pager, which is nice. So one of the things that you may have noticed in this unit is that some of the sections don't have a lot of homework or a lot of interesting problems associated with them. And if you look at the homework, you see that we ask questions related to previous sections. And I think you'll see something similar going on in Part D homework. It's not all about this unit. We're just really adding another little concept on top of the ones that you already have, and in the homework, practicing many different things, not just this. So you've seen before in the previous sections that we had the sine and cosine angle sum and angle difference formulas. You know, the sum of sine of the a plus b would be sine of a cosine of b plus cosine of a sine of b. Sine, cosine, cosine, sine. And same thing with cosine, we've got a little formula for that. So then that raises the question, what do you get if you have the sum of two angles passed into the tangent formula? So that's what this is about, and we can actually derive that. So we're going to make use of the fact that the tangent of theta is equal to the sine of theta over the cosine of theta. And let's look at what tangent of a plus or minus b becomes. So most of this is actually this hairy algebra that's done for you, but we do give you a little bit of work to do yourself, and we just present it here to give you the idea that this is not magic. This is not some mysterious formula that comes down from who knows where. This is all stuff that you can actually figure out if you needed to. It's just a little messy. So if we have the tangent of a plus or minus b, that certainly would be the same as the sine of a plus or minus b over the cosine of a plus or minus b. And we can use the angle sum and difference formula for sine and the angle sum and difference formula for cosine and write it like that. Now, to simplify this, there's a little trick that we do. We're going to take the numerator and the denominator of this fraction that we got, and we're going to divide them both by cosine of a, cosine of b. So we're not really changing the value of this fraction. We're changing the form of it by dividing the numerator and the denominator by the same thing. And that's expressed here. You can see that the numerator is divided by cosine A cosine B, and the denominator is divided by cosine A cosine B. And when you expand that all out, you get this wonderful fraction that has this messy fraction in the numerator and another messy fraction in the denominator. And then, at that point, we say to you, okay, simplify the right-hand side. Well, it's not actually that bad. Let's see if we can, let me expand this a little bit so you can see what we're doing. And right away, if I look in here closely, I can see some things that are going to cancel. So in this little fraction here, I have cosine b over cosine b. I go, yippee. I want to get rid of that, so I'm going to cancel that part. If I move to the right, the next little fraction in the numerator, I have a cosine A over cosine A. That goes away. Now, as I've said before, you can't get away with murder here. You can't take this b over b and cancel that, because this isn't just b over b. This is sine of b, and this is cosine of b. Now, sine of b and cosine of b are not the same thing. You can't go around canceling that willy-nilly. Likewise, sine of a and cosine of a, you can't cancel the a's independently. That just does not work. And moving further down, we have another thing that we can cancel. I like that. And then moving further to the right, there isn't much that I can do there. All right. Now, let's take a look at what we've got and go to work. So sine of a over cosine of a, that's really the definition of tangent of a. Tangent of a is sine of a over cosine of a. So I can convert this back into just plain old tangent of A. So that takes care of that little fraction on the left-hand side of the numerator. And then we've got this operator, which is the plus or minus. And then let's look at this fraction. There I've got sine of b over cosine of b. Well, that's just the tangent of b. Now that takes care of the numerator of my big scary fraction. Going down to the denominator on the left-hand side, I have cosine A over cosine A. Well, that's got to be just 1, because the numerator and denominator there are the same. That's 1. Oh yeah, this thing came down here. That was tangent B. And you'll notice that the operator here is not plus or minus. It's minus or plus. So we need to use minus or plus. And I'll talk about that again in a bit. Moving further to the right, we have sine of A over cosine of A. That's tangent of A again. Times sine of B over cosine of B, which again is tangent of B. So let's sum it up here. There wasn't a lot of work to do there, really. Your final answer should be in terms of tan of A and tan of B only. Yep, it is. And so at the bottom, all we're doing is taking that and writing it again. The reason that we're doing this again separately is to make sure that the version of this formula that you have in your notes has these operations done in the right way. This is plus or minus. This is minus plus, minus or plus. That is important. So this ended up being tangent of A. This is a tangent of B. 1 minus or plus tangent of A times tangent of B. So things to look out for. Tan A, tan B, these are multiplied together. There's no operator shown here, so when that happens, you assume it's multiplication, which it is. When you're taking the tangent of the sum of two angles, tangent of A plus B, then when you use this equation or this formula, you want to use the plus here and the minus here. That's why this operator is flipped upside down compared to this one. So when this is plus, and this is minus. Now, when you do tangent of A minus B, you'll have a minus sign here. In that case, you use a minus sign here, and you use a plus sign here. So whatever sign you have here is the opposite of whatever sign you have here. Whatever sign you have here matches the sign that's in the original expression, tangent of A plus or minus B. Okay, that's it for part D.